Howdy, and welcome to my channel. This is a project video on a remote power supply switch box. It is probably going to be the simplest project I ever have on my channel. The funny thing, however, is that it is also a device that I have used the most often, so, go figure. In this video, I will show the problem, the fix, and then an example of connecting a power supply with a switch box to a breadboard with an operational amplifier. Since this is for hobbyists and people getting into experimenting with electronics, this would be a great first project, and many, I think, would find it most useful. Starting out, probably the first two instruments you'd want for your workbench are a power supply and a digital multimeter. And then the switch box would be helpful when experimenting with breadboard circuits. Okay, so taking a look at the problem, here I have an inexpensive power supply. It's the Maztec HY3003D. Sells approximately online, checking today, at about $70 US dollars. And this is a CORAD, and it's the model KA3005P. And again, checking today, around $140 to about $190. And the big difference I want to kind of home in on this particular video is that this particular unit, the more expensive one, has an output on-off switch, and this unit does not. So, for example, if I wanted to hook up something to the power supplies, going with the least expensive one here first, I could make the connections into here and hook it up to, say, a protoboard or breadboard. When I wanted to make changes to that, I would have to somehow disrupt the power. And one of the ways I could do that is actually pull one of the leads out of the 5-way binding post here. Or, possibly even worse, turn the voltage all the way down and then turn the voltage all the way back up, having to reset it again. And another possibility would be to use the power on-off switch and just simply cycle the supply. Again, on an inexpensive power supply, I might have to be concerned with what are the turn-on transients and is there overshoot on this thing. The other thing is, at least for me, when I'm dealing with a breadboard or protoboard, making changes to a circuit, I may be doing a dozen times I want to cycle the power while I'm working on it, like within an hour. So all of this gets kind of old really quick. A nicer, more elegant way to do it is to use this on-off. So if I come over here and connect up my leads to the power supply, what we have is also a 12-volt set here, and I set a current limit here at 30 milliamps, and I should mention this one you could set also. And then I would simply engage this button, and this would turn the output on. And since I don't have anything really connected to it right at this moment, you can see we're reading 0 current, but we're at our 12 volts. Now what I can do is I can just simply cycle it on and off as I'm working on the protoboard. So much easier, much more convenient way of doing it. But again, difference in price. Unfortunately, for me, it actually gets worse because, again, I like to do a lot of op-amp circuitry. Most of the op-amps are DC coupled for me, so I want to use a split power supply. So here are two tri-power supplies. I have a supply here, an output here that are isolated from one another. I have 5-volt fixed, and up here then I have also the same kind of thing. The one here in the bottom is a Maztec, and it's the HY3003D-3. And again, checking today, it's about $120 to $190. The Rigel up here, which is a much more sophisticated power supply, is the DP832. And again, looking online, around $450 to $550. I did get the options on this, so when you do enable an output, you get an extra digit, so you're down to the 1 milliamp and 1 millivolt resolution. And as you can see on the stop one here, there are buttons to turn the outputs on and off, or you could turn them all off, for example. So that really is a nice feature, but I only had this recently, maybe the last year. I've had this for maybe 10 years. And on this particular unit, there is no on-off output. So looking at the bottom power supply, it doesn't have the on-off switch, but it does have some nice modes here. Also the top one would do it too, but you have independent, where this power supply is controlled by these, and this power supply is controlled by these particular knobs. You also have series tracking, and you have parallel, where it basically puts these two in parallel with those so you can increase your current. Most of the time I'm running in series tracking, so I push this in And then you could probably hear a relay that was clicking. And that clicking is, it's doing a couple things, but one thing is it's connecting these two posts together. So it's like I have one battery here, and they're in series, and this becomes the common, these two connections right here. So then what I can do is, if I was going to connect this up, use whatever kind of color coding you'd like, I'm going to take the red for my positive, push it into here, and then I can plug into either one of these a common reference. I'll use green for that, not to be confused with chassis ground. I can plug it into this one or this one, since they're connected together. And then for the negative supply, I'll use black, again, it's just my convention, and put it into here. And now I'm running a split power supply between these. So if I stand at this node and look up at here at this connection, that's a plus 15 volts. If I stand at the node here and look down, I'm looking down at a minus 15 volts. The problem comes into play is now as you're making all kinds of changes to your circuit, how do you disconnect the output since there's no output button? One thing, if I pull this, I've still got the negative there, so I'd actually have to reach in and grab both of them, I guess, at the same time and try to pull them out. Another one is I could turn the master, since they both track, all the way down to 0, make the changes to my circuit and adjust them back up. Again, that's a pretty old hat, like we showed before. And I could also cycle the power supply, worried about also turn on transients and overshoots. So it'd be nice if there's a little bit cleaner way to do that. And that's why I'm getting into this remote switching unit. As mentioned, this is a simple project, but I want to be consistent providing support materials. So please go to Tiger Multimedia and click on the projects link, which is located in the left navigational bar. Then select this project to get support materials. If, for example, a PDF file of the PowerPoint slides, several pictures of the project, bill of materials, and information in text format. This is a schematic diagram of my Switchbox and setup. I set my power supply to series tracking, and I am showing by using a dashed line that V1 and V2 are tracking via master's control. From the power supply, I use 3 banana plugs that have red, green, and black colored wires. These wires go to the Switchbox, and the red and the black wires are connected to 2 poles of the switch, SW1. The diagram shows a double pole, double throw switch, because that's the most common for me, but of course a double pole, single throw switch would work just fine. The switched red and black wires leave the switch box while the green common wire just passes directly through it. This configuration allows me to connect or disconnect the 2 power supplies from the breadboard at the same time, and that is great for many operational amplifier circuits. So let's take a look at the components of this project. An on-off dual pole, single throw, or double throw switch is used. I would not recommend a center off switch for this application, just get the basic on-off type. Also be sure and get a switch properly rated for the voltages and currents you wish to control. I'm using a 6 amp 125 volt toggle switch. Next you'll need some type of enclosure. I'm using a 3.5 inch by 2 inch by 1.5 inch or 9 centimeters by 5 centimeters by 4 centimeters plastic case. Most any small size enclosure will work. 2 plastic cable clamps are for cable strain relief. I like to have some additional cable management using heat shrink and spiral wrap. Next, some fasteners for the cable clamps, and if not included, some screws for the enclosure. Here I'm showing one red banana test lead. For this project, I like to use these banana test leads and then just cut them in half. This way I get a nice molded connectors at the ends. You'll probably need 3 of these test leads of varying colors. I use Pomona cables, which are good quality. Then you might like to optionally use 3 matching colored female banana connectors or sockets. Finally, 4 rubber feet for the bottom of the enclosure. And these are only suggestions, and of course there is a large variety of ways to make this unit by using different connectors. It just depends on your personal needs. And here's the fix to the problem. It's a remote switch box that I made a couple of years ago. I've actually made these that go back maybe 20 years. I've used them a lot and they're very handy. This one has some banana connectors at the end. Notice it's got the 3 leads for me because I like the split power supply capability. And then it also has 3 over here. And they were originally terminated in this. I was just cutting these in 2 in the middle and making the connections. But recently I added a female 5-way binding post so that I could plug in additional connectors and stuff, and a little bit more versatile. A little bit of strain relief, rubber feet on the bottom, a couple screw heads there for the strain relief inside, and a double pole, double throw switch. Then the way that you would work this, you would simply just connect it up to the power supply. And so we'll take a look at that. So again, like last time for connecting to this dual supply, I would put the red into here, the green connection there, and plug it right into this position. And now I have my switch box hooked up. Okay, let's take a closer look at the end cabling. What I did was originally I had these connections like this, just they were cut in the center and just brought out. But then just recently in the last few days, I cut them off and I put on these female connections. And off of eBay you can get a big pack of connectors. These are again the female banana. They seem to be pretty decent and they weren't very expensive. And again, multicolor is important. Then what I did is at the other end of the cable, and kind of zoom in on that too. You can see I have a little pin here, and then I use some heat shrink. And this is really nice because it will go into the proto board. And so you can use DuPont male connectors, which are a really nice choice because you've got the crimp capability here and then the heat shrink over it. Makes a good bonding. If you don't have that, some old wire wrap sockets you could just snip off and then use this particular metal for your pin. And a lot of people I know are doing the little microprocessor boards, and then you have inline pin headers, that you can buy separately, and then clip a couple of those off. So lots of possibilities. You could even just use solid wire, 18 gauge or something, or no, I guess a little smaller, 22 gauge, and tack it on there. Again, doing it this way, adding the female connectors on there, just makes it a lot more versatile. So for example, I just unplug that, and then if I want, I can use a banana jack and plug it in there. Then I, of course, am terminating at the end with another banana jack. And there are proto boards that have 5-way binding posts, and you just simply plug right into it that way. You also could put on alligator clips that could snap on the end. This obviously is a non-insulated one, but you can get them with the insulation boots on them. And again, you can make all kinds of different types of connectors, and you can just plug into here. So it's just trying to make the unit a little bit more versatile. Okay, the last thing I mentioned in that bulleted list, here's a operational amplifier using a 741. And I just kind of breadboarded one up here to kind of show the idea of this remote switch box. And I would recommend that you try to, again, like I said, colorize things like green for your common, black for the most negative, red for the most positive, and then these are the power supply bus rails that run across there. And here I just got a really simple non-inverting amplifier with a gain of 10 set up. So we can show how we would hook that in, make the measurement, and show a practical utility of using that switch box. And basically what I've done is I hooked up a scope probe here to the input. This is from a arbitrary function generator. And then I have the output of the op amp connected to channel 2, or the blue one, scope probe. And then over here I stripped off a little extra insulation on my connector wire, and then I clipped all my grounds together into one place on the ground rail. And one thing I should mention, a lot of times, and I'm guilty of this, is sometimes you grab your scope probe right across one of the resistors. Problem is, with the weight of the resistor, with the weight of the scope probe, it can pull the resistor out of the socket. So it's always nice to kind of have strain relief wires right there. And as mentioned, color coding those are nice. So go ahead and, since I've got the pins, I'll just pull these wires out and just connect them directly in. So here's my switch box, and make the connections to it. Again, it's in the off position. You can mark this, of course, but I just simply made the switch when it points towards the power supply, it's off. When it points this direction, it's on. So when you flip it towards the proto board, turns it on, that turns it off. Remember, we're switching both the positive and negative rails. So put the positive in there, the common or ground signal reference there, whoops, off by one hole, and then the negative into this position. So again, you can see it's a nice utility, really easy to hook up. The next thing I might want to show you is just some decoupling. One of the things is, of course, we have a bunch of leads here and some links going back to the power supply. So you've got inductance, capacitance, and this is a power supply that doesn't support remote sensing in terms for regulation, but you also kind of have to worry about decoupling. So let me zoom in here, and I'll tilt this up. And what you can see, if I can get it positioned right, gee, that was fun. All right, there we go. Put that out of the way. What you can see right here is I have some electrolytic capacitors, and I'd recommend 10 microfarad to about 47 microfarad capacitors. And I have them from the positive to the common, and also from the negative to the common. Be very careful, don't forget that one of the capacitors, positive, is going to go to the ground because the other lead goes to the more minus, so it is more negative. And then these are good for smoothing and putting a little bit of energy storage there for you remotely from the power supply. And the other thing is you should probably shunt them with disc capacitors, like 0.1 to 0.01 ceramic discs. Don Lancaster years ago had a nice article on electrolytic capacitors that even can become resonant circuits at certain frequencies. So we're using the electrolytics for, like I said, smoothing, storing some energy, a little bit of energy there, and we're using the disc capacitors for higher frequency decoupling and suppression. And it's a little bit magic, because occasionally sometimes it can make a circuit become unstable, and sometimes you have to juggle the values around or even bridge across both the positive and negative with a, say for example, a disc capacitor. So that's part of the tinkering process. So here we have the function generator set to 1 kilohertz sinusoidal wave, and it's 2 volts peak to peak. And then what we've done is we brought it down here and connected it into our little operational amplifier. Like I said, that has a gain of 10, and then we can monitor that output on the oscilloscope. So with the power off, you can see that we have our sine wave at the input there, and I'm checking it. And then the utility is I can, of course, come in here, and I could be working on the circuit, and then just simply flip this switch, and I've applied my plus or minus 15 volts to it, and then I can check. And I know you probably can't see it here, but one's 1 volt per centimeter, one's 10 volts per centimeter division. So effectively there is a gain of 10, putting in 2 volts peak to peak and getting out 20 volts peak to peak. Then say you want to make a modification or something, that's where the problem comes in when you want to reach in here and make some adjustments. You can just flip this thing off. You can see it just rests really comfortably with your hand, and you can be clicking this thing on and off all day long without any problem. So maybe I want to change the gain. I have a 10 k ohm in the feedback path of the op-amp with a 1 k ohm Rn, so I'll just simply change that RF feedback resistor from 10 k down to 1 k, and then I'll get a gain of unity or a gain of 1. So if I just flip that switch off, I can pull that resistor out, and then I can put in the new resistor. So I'll go ahead and do that. And now I've replaced that 10 k resistor with a 1 k ohm resistor. Flip the unit on, and you can of course see on the oscilloscope the gain is much lower. And I could then increase so that they're equal. Now they're both 1 volt per division. And so I have 2 volts peak to peak input, 2 volts peak to peak output. And so of course I have unity gain. And again, it just shows the real utility of a little simple power switch like that. Another thing is it brings the switch closer to the proto board. I'm not reaching way back or up on another shelf, just flipping it locally. So probably a bit of overkill for just a switch and some wires, but I find it really useful. I'm easily amused, so hopefully some of you might want to build something like that. I think you might enjoy it. And another quick comment is, of course, even though it has the 3 connections, you can definitely use it on a single supply. So I simply plug in the red into here, the black into there. And now actually I'm totally disconnecting the power supply, because if you remember, there's a dual pole switch. So flipping that, we're disconnecting both the positive and negative lead of the power supply. One last comment that I kind of thought of, I should have mentioned. Again, I'm using green. If you check my AC power supply video, I go through a lot of detail of chassis grounds, things like that. And a lot of times that's what it is. It's a chassis ground. But if you note, when I was using this for a split supply, and I was using this as my common signal path, as soon as you connect up your scope probes, ground leads, and your signal generators leads and everything, this does become generally a chassis ground, back to earth ground, becomes a common ground. I hope you enjoyed this video, and if you did, please give it a thumbs up and subscribe. And again, thank you for watching.